Today we're going to talk about derivatives of trigonometric functions. But first I need to go over with you some trig formulas, the sum and difference formulas. So the sine of two angles being added, u plus v, would be the sine of u times the cosine of v plus the cosine of u times the sine of v. The cosine of two angles being added together, u and v, would be the cosine of u times the cosine of v minus the sine of u times the sine of v. The sine of u minus v would be the sine of u times the cosine of v minus the cosine of u times the sine of v. And the cosine of u minus v would be the cosine of u times the cosine of v plus the sine of u times the sine of v. And we'll end up using that when we try to do this next part where we want to find the derivative of the sine of x. Now remember, if you don't have a derivative rule, we'll have to go back to our limit definition of the derivative. The limit as h approaches 0 of f of x plus h minus f of x all over h. So our function is the sine of x, so f of x plus h would be the sine of x plus h. So we have the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. Notice we're taking the sign of a sum there, the sine of x plus h. Using that sum formula we just went over, we have the limit as h approaches 0 of the sine of x times the cosine of h plus the cosine of x times the sine of h minus the sine of x all over h. So now I'm actually going to switch these two terms here. And I have the limit as h approaches 0 of the sine of x times the cosine of h minus the sine of x, and then plus the cosine of x times the sine of h all over h. And so now I'm going to concentrate on these two terms here. If you notice, they both have a sign in common, but I'm actually not going to factor out a sign. I'm going to factor out a negative sign. And when I do that, when I have this negative sign right here, that will make this a negative cosine, because a negative times a negative would give me that positive. And that'll be a plus 1 because that negative sign times 1 will give me that minus sign. And I'm still taking the limit as h approaches 0, and this part is just staying alone, and it's still all over h. Okay. So now I'm going to separate these two fractions. I'm going to take this negative sign times negative cosine of h plus 1 all over h, plus the cosine of x sine of h all over h. So I'm separating that fraction. If you look at it like denominators, you could add their numerators over that denominator, so I'm undoing that, if you will. Now, applying my limit laws, the limit as h approaches 0 of these two things being added together would be the limit of the first plus the limit of the second. So here I have the limit as h approaches 0 of that negative sine of x times 1 minus the cosine of h all over h, plus the limit as h approaches 0 of the cosine of x times the sine of h all over h. Now, look here. I'm noticing where the h is approaching 0. Sine of x is completely unaffected by that. Here, the limit as h is approaching 0, the cosine of x is completely unaffected by that. So those are essentially just coefficients, and I can pull those coefficients out. So I have negative sine of x times the limit as h approaches 0 of 1 minus the cosine of h over h, plus the cosine of x times the limit as h approaches 0 of the sine of h over h. These two limits should look familiar to you. These are our two special limits. The limit as h approaches 0 of 1 minus the cosine of h all over h is, if you recall, 0. And the limit as h approaches 0 of the sine of h over h would give us 1. So those are two special limits. Anything times 0 goes away, cosine times 1, and we're just left with the cosine. So it turns out that the derivative of the sine of x is the cosine of x. Now you can do an incredibly similar process to find the derivative of the cosine of x, and you'll see that you end up with negative sine of x. So we have the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. Now let's look at the tangent of x. Well, remember, what is tangent? Tangent is sine over cosine. So if I wanted to take the derivative of sine over cosine, I know the derivative of sine, that's cosine, and I know the derivative of cosine, that's negative sine, so I can actually just apply the quotient rule here. So that's the derivative of the top, which is cosine, times the bottom, cosine, minus the top, which is sine, times the derivative of the bottom, which is negative sine, all over the bottom squared. Now cosine times cosine will be cosine squared. Negative sine times negative sine will be sine squared. So I have the cosine squared of x plus the sine squared of x all over cosine squared of x. Well, from our Pythagorean theorem, or Pythagorean identities, we know that cosine squared plus sine squared is 1. So that gives us 1 over the cosine squared of x. And 1 over cosine is the secant, so 1 over cosine squared is the secant squared. So it turns out that the derivative of the tangent of x is secant squared of x. Now you can do a very similar thing using the quotient rule for the cotangent, knowing that the cotangent is cosine over sine, and you'll get that the derivative of the cotangent of x is negative cosecant squared of x. All right, next up, we'll look at the derivative of the secant of x. Remember, what is the secant of x? That's 1 over cosine. So if we wanted to, we could apply the quotient rule here again, which would be the derivative of the top, 0, times the bottom, cosine of x, minus the top, 1, times the derivative of the bottom, negative sine of x, all over the bottom, cosine of x squared. So 0 times anything goes away. Negative 1 times negative sine gives me a positive sign, so I have sine over cosine squared of x. Well, what does it mean to multiply something to itself, or square something that's cosine times cosine? So I have sine over cosine times cosine, which I can break up to 1 over cosine of x times sine over cosine. And 1 over cosine is the secant, sine over cosine is the tangent, so the derivative of the secant is secant of x times tangent of x. Now, there's another way we can do that. We've talked about before how if you don't have a variable in the numerator and the denominator, you don't have to use the quotient rule. Notice there's no variable here. We can actually bring the cosine up and give it a negative exponent. That's the same thing as cosine of x being raised to the negative 1. So we could take the derivative using the chain rule. Bring the exponent down, leave the inside function alone, take 1 away for the new exponent, and then multiply it to the derivative of that inside function. Now that negative 1 times negative sign becomes a positive sign, and to get rid of that negative exponent, we drop it down to the denominator. And notice we just had this, we have sine over cosine squared. That's the same thing as 1 over cosine times sine over cosine, which is the same thing as secant times tangent. So either way you do it, you get that the derivative of the secant of x is secant of x times tangent of x. And you can do a very similar thing to find the derivative of the cosecant of x, and you'll get that the derivative of the cosecant of x is negative cosecant of x times the cotangent of x. So there's the derivative of those 6 functions, those 6 trig functions, sine, cosine, tangent, cotangent, secant, and cosecant. Well, what about our inverse trig functions? Well, first let's talk about finding the derivative of an inverse function in general. Well, if you recall, when we talk about inverse functions, we say that f and f inverse are inverses of one another for sure. When you compose them together or you stick one inside the other, you get x. So if you recall, f evaluated at f inverse of x is equal to x. So let's start with this. Let's differentiate this, both sides, with respect to x. So let's take the derivative of f inverse of x with respect to x, and the derivative of x with respect to x. Now, here we're taking the derivative of a function inside a function, so we'll apply the chain rule. So that'll be the derivative of the outside function, leave the inside function alone, and then multiply it to the derivative of that inside function. And that right there is the derivative of the inverse function, equals the derivative of x with respect to x is 1. Now, what are we trying to do? We're trying to find the derivative of the inverse function. What is this right here? The derivative of the inverse function. So to get this alone, we can just divide both sides by f prime at f inverse, and we can see that the derivative of an inverse function is 1 over the derivative of your original function evaluated at your inverse function. So we can use that to find the derivative of our inverse trig functions. So let's see an example of that. Let's find the derivative of the arc sine of x. So we just said that the derivative of an inverse function is 1 over the derivative of the regular function evaluated at the inverse function. So here arc sine is an inverse function, so that is my f inverse. And that is the inverse of the sine of x, so my original function is sine of x. Now remember, what is arc sine? Arc sine gives us an angle. So if arc sine is equal to theta, arc sine of x equals theta, that means that the sine of theta is equal to x. So we can make a right triangle here if we wanted to. So sine is x, which is x over 1. Remember, with right triangle trigonometry, sine is opposite over hypotenuse. So the opposite would be x and the hypotenuse would be 1. And then we could say, okay, opposite over hypotenuse, then we could do x squared plus this leg squared would equal 1 squared using the Pythagorean theorem, and we would see that this leg right here is the square root of 1 minus x squared. So now let's apply this to figure out the derivative of the arc sine. So the derivative of the arc sine will be 1 over the derivative of the original function. Well, the derivative of sine is cosine, evaluated at the inverse function, which is arc sine. Well, we just said that the arc sine of x is equal to theta, so that's the same thing as saying 1 over cosine of theta, because that arc sine of x is that angle theta. Well, we can find, with this triangle, the cosine, which will be adjacent over hypotenuse. So the cosine of that angle is square root of 1 minus x squared over the hypotenuse of 1. Well, anything divided by 1 is just itself. So really the derivative of the arc sine of x is 1 over the square root of 1 minus x squared. And you can do very similar things to be able to find the derivative of all the other inverse trig functions. So let's put it all together and we'll see that the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent. And the derivative of cosecant is negative cosecant times cotangent. We showed all those. Now, doing that method with finding the inverse trig functions, you would see that the derivative of the inverse sine is 1 over the square root of 1 minus x squared. Do a very similar thing, you'd see that the derivative of the inverse cosine is negative 1 over the square root of 1 minus x squared. The derivative of the inverse tangent is 1 over 1 plus x squared. The derivative of the inverse cotangent would be negative 1 over 1 plus x squared. The derivative of the inverse secant would be 1 over the absolute value of x times the square root of x squared minus 1. And the derivative of the cosecant inverse would be negative 1 over the absolute value of x times the square root of x squared minus 1. So there's your derivatives of all your trig functions. You've got your 6 trig functions plus the inverse trig functions of all of those. And those are what their derivatives are. So, see you next time.